lab file. I could find it. Okay. So for this lab, well, you can see these pages right here. This one gives you details about the available GitHub hosted runners. You can see they have different flavors: Windows Server 2022, Ubuntu, and Mac OS. And in the following link, you can see the events that trigger the workflows. It's also useful. So let's get started with exercise number 2. And it says here that we're going to go back to our repository that we created in the previous exercise. Then we're going to click on the Settings tab. Then we're going to locate Code and Automation. Okay, this is Code and Automation. And we're going to expand the Actions menu and click on Runners. You can see this repository has no runners configured. So let's go ahead and click on the New Self-Hosted Runner button that you see right here at the top right with the green background. All right, so depending on the operating system you're using, select it right here as well as the architecture. I'm on Windows, so I'm going to select this and this architecture. Go ahead and open a terminal window. Well, I already have one open. If you're doing this on Windows, make sure your terminal window is run as administrator. Otherwise, you won't be able to register the service for the runner. And it actually says that in the instructions. So go ahead and head on over to C. I'm going to make this folder directly from where I'm currently standing in Shell. Let's go ahead and cd into that. And right there, you don't have to type that command. You can just copy it from the instructions here at the window. So this command is this one right here. It's going to download the zip file which contains the installer for our GitHub runner agent. So go ahead and run that command from the Actions runner directory. Going to use PowerShell instead. Remember to run as an administrator. I can't deal with maximized windows. All right, so cd the. All right, now let's go ahead and paste that command. Yeah, I switched to PowerShell. Yeah, I don't know why it occurred to me to open CMD. Yeah, I never use CMD. I don't know why it occurred to me to use it on this occasion. Yeah, instead of CMD, use PowerShell. Open PowerShell as administrator so that you can run the invoke web request command. And someone asked if we can execute batch files using the run command. Yes, we can. We can execute scripts and all types of files. For example, if it's a Python script, you can also use Python shell for that. Or yeah. No, there's no. Someone asked if we can add a self-hosted runner in an agent pool like we do with Azure DevOps, and the answer is no. I didn't see. I don't think they have a pool of runners in GitHub like they do in Azure DevOps or GitLab. And someone asked if we can set up self-hosted runners on Kubernetes. I didn't see that option. I don't think they have it as of yet, though it's weird because all the major platforms do support Kubernetes runners, so I think it should be coming really soon. Oh, if you're on Mac OS, you can just select runner image for Mac OS. And these commands right here will be replaced by the ones you need for your operating system. All right, so the file has been downloaded to my system. You can see it right here. And the next thing will be to validate the file hash, to validate the integrity of the file. I mean, I know I downloaded it from the GitHub tool, but better be safe. It's a good practice to run that. So just going to run that command to be on the safe side. So if it was not the file it says it is, we would have seen this message right here. So since it did not come out with a message, it means everything is fine with the file we downloaded. All right, so now we're going to extract this file. Just going to continue copying and pasting these commands. And this is basically going to uncompress this file in the current directory I'm standing in. So if I do ls now, I can see all its contents uncompressed. And now we're going to register this runner. And to do so, let me just see if I'm following the steps of the guide. Yeah, it's all good. Okay. So the next part will be to run this command within the configure block. And this will register our runner. You can see it has the URL of our repository and a token which will allow it to authenticate. So just hit enter. Did I not hit enter? Okay, there we are. Right, so I'm going to leave the default values for everything, such as the runner group or name of the runner and labels. But, okay, the work folder, I'm going to leave the default. And I do want to run it as a service. So press yes. And I'm going to leave the default NT-Authority network service account for the service. And there's our runner. And if we go back to GitHub and click on runners, we should see it appear with this little green circle right there, meaning that it's online. And we can also run if you're having issues with your runner, you can run that cmd command, and it will try to get it to run. But since mine is already running, it says it's already running and there's nothing to do with it. It will just keep retrying. So I'm going to leave it as it is. Let me refresh to see if my runner is still online. It is. Okay, so now we're ready to test our runner. So let's go ahead and click on code. It will take us to the main page of our repository. We're going to add file, create new file. And here at the top part, we're going to create the directory structure for the workflow file. It has to be .github dash workflows. Slash workflows. And then the name of your workflow file. I'm going to call this first workflow.yaml. And we're going to do, we can copy and paste the code I have in the file right there. Let me just see if it preserves the spacing. Yeah, and it looks like it did. No, it didn't. So yeah, we're going to have to tweak it a little bit. So you can see here it's only one space. It has to be two. So just make this look like the screenshot I put in the document, the lab document. I definitely miss those little dots from Azure DevOps to see where everything is landing on. Wait a minute. Yeah. I think it would have been easier to just type everything. So here we have our very first workflow. Here's the name of the workflow. Here is the trigger. This is the manual trigger. I have to go into Github Actions and tell it to launch this pipeline. Here's our jobs key, which holds the jobs in my workflow file. Here is the first, here's where I specify what server or machine is going to execute this job. And you can see it's self-hosted, meaning that it will be picked up by the runner we just configured in our local system. Next, we have the first step, which here it's called first job script. It's going to use the CMD shell, and it's going to run this echo hello world command. The second job runs on GitHub's runners. In this case, it would be the Ubuntu latest. And it has the following steps, which is using bash as a shell. This is its name. And the command that's going to be run, you remember I told you that we can have multi-line scripts. And that is done or configured when you put this pipe right here. So this means that everything within run is going to be executed. And I see I have a spacing error right there. So these two lines are going to be executed in this run command. All right. So someone asked, where did I get the token for the runner? That appears automatically when you go to settings, actions, runners. You will actually see that every time you click on new self-hosted runner, it changes. Where is it? Here. And another thing is that if you want to programmatically set up runners, you can use the API to do so. So you can get the token from the API as well. Okay, someone asked if you have a job that needs to run on self-hosted runner on Windows and another job on self-hosted Ubuntu, how do I do that? Well, you would need another machine, in this case with that operating system. So you need a machine with Windows and set up the GitHub runner right there, and a machine with Ubuntu and set up the runner right there. Okay, someone asked if there will be a recording of this, and yes, there will be a recording. It will be made available. Okay, so we already saw steps. Yeah, we already saw steps. All right, so to use actions, to integrate them into our workflow, the keyword we need to use is the uses keyword that you see right there. It will allow us to add actions, which, as we already know by now, are kind of like pre-made tasks or scripts. GitHub defines it as reusable units of code. So instead of rewriting code, we can just import it and build upon it, whether it's our own code, code from a vendor to deploy on their service, tools, etc. The syntax is as follows. You have the uses keyword followed by the value, which is, for example, actions, like you see in the syntax right there at the bottom in the slide. You have actions slash the name of the action, then the @ symbol, then the version, could be the version, the commit in the repository, or a branch. And we can view several actions in the GitHub marketplace, like we've already seen in the past two exercises. We can see it from the sidebar when we're editing a workflow file, or we can see it at the very top in the link that takes us to the marketplace. Or if we open GitHub, it just github.com and /actions, it can take us to the actions by GitHub, their official actions, and we will see that in the next exercise. So after you add an action, within that same block of code of the action, you may have to add several key value pairs according to the instructions of the action. These are added with the with keyword, and each action should include some documentation that includes a section called usage and some examples on how that action can be used. The jobs in the workflow, well, actually, let's go over that slide. You can see that we have an example of a job, and its only job within it is called job with GH actions. It specifies the runner or machine that is going to execute that job, which is Ubuntu latest. And we've already seen that that is a GitHub hosted runner. And next, the following steps, which are all GitHub actions. Why? Because it uses the uses keyword. Instead of step, instead of run, like we've seen in the past slides, it is the uses keyword. And you can see there that we have the actions, like that would be the repository or an action from the marketplace. Then the name of the action and its version. So the first one is the checkout version, which is an action that will allow us to git clone our repository into the server that's going to be running the job, in this case the Ubuntu latest job. Then we have another action called setup node version 3, and it's basically to tell that machine to use node version 16. Then we have another action made by a user, a GitHub user, a random user. And you can see we're pulling an action from his hello action repository. And you can see the full commit SHA. It starts with 3DC69 and ends with 830. And you can see it has a parameter in which we specify who is going to be greeted. In this case, live lesson attendees. The one that is called setup node at v3 also has an input parameter that in which we specify the node version that we want on that GitHub action. So variables in GitHub are known as environment variables. And these can be accessible depending on the level in which you define them. For example, if you define a variable at the workflow level, at the very top of the workflow file, then that variable will be available to all the jobs and steps in your workflow. If you define it at the job level, then it will be available to all the steps of that particular job. And if you define it at the step level, then it will only be available to that particular step. So if you try to call that variable from another job or another step, it's not going to work. That's going to give you the value. The syntax for using a variable is the $, parentheses, and the variable name. And, well, one thing to note is that a good naming convention is to keep environment variables all caps with underscores as spaces. So I'm going to fix that slide. Variable and underscore name should be all in caps. And something really important in Git repositories is that you should be extremely careful about secrets or sensitive data. You should never commit that into your repository. Instead, we're going to see a way in which you can secure your sensitive data or your private keys in case you need it to authenticate to a cloud service, in case you're going to deploy, or in case you're going to pull the data from another application or authenticate to a container registry and so forth. So you don't put that data, passwords, or anything in the code of the YAML file or in anything you push to the repository. You set that up in GitHub Secrets or a key vault if you integrate that into your repository. And we're going to see that in the next exercise. And the way you can use a secret in your workflow, you see the syntax right there. It's the $, 2 curly braces, 2 opening curly braces, the keyword secrets, dot, and the name of your secret. You can see that one I did put in caps. And then you just close the curly braces. All right, and some tips on naming secrets is that you should only use alphanumeric or underscore characters. It must not start with the GitHub prefix because there are other variables called predefined variables that start with that prefix, so you cannot use that prefix. And the secrets cannot start with a number and are not case sensitive, though. It's ideal to keep them all in all caps. So, no, the who to greet is not a predefined parameter. Well, yeah, it is a parameter, but you can change it. So you can change it to greet Lara, to greet John, and so forth. So yeah, it is mentioned in that GitHub action, and we're actually going to see it in the next exercise, how we can play with that parameter. So we're talking about default environment variables. And here you can see a list of those variables. And these contain very useful values that can help us with our automation, or they can be useful for your workflows. Some of them can give you like the ID of the job, the reference in Git, like the head, the main, branch, so forth. It can give you details about the runner operating system, its path, and more. And there's a link for that as well. You can see all the predefined or default environment variables. And to the right, we have an example of variables declared at different levels and how they are displayed. And that's actually part of the exercise we're going to be doing now. All right, so I'm going to share my screen now.